Welcome, guys, to your first lesson in iOS development. Before we can begin making our breakthrough app, we need to have a good, solid understanding of our Swift fundamentals. So today, we will begin by looking at variables and how they are declared and the different types that we may encounter. So, to begin, the assumption is that you already have Xcode downloaded. If not, you can pause this video and go to the App Store and download it for free. It is a big download, so you may have to wait a bit. Also, make sure to open it because sometimes there are additional components you need to install, and that also may take a while. But assuming that you've done all that and you are here on the welcome screen in Xcode, we can begin. Let's go ahead and click on the Get Started with a Playground to open up a playground. You will be prompted to select a playground, and we can go ahead and select blank. And we can call it anything. For this case, we can call it variable since that is going to be the main topic of today's lesson. Go ahead and hit create. And you will be greeted with a screen like this. Now I'm going to maximize it and zoom in a little. So now that we have the size that we want, we can begin coding. The first thing you may notice is that there is some placeholder code already written inside. The first thing on top says import UI kit. For now, we don't have to worry about this too much. Suffice to say that it is what lets our computer get the toolbox that we need to work with the code that we will be working with. By standard, you will have this always, and in case it erases for some reason, you can write it in yourself. All you gotta do is write the keyword import, and then look for UI kit, and it comes up. Again, just standard procedure for now. We will later explore what this actually does once we start getting into needing different toolboxes for different situations. Below, you will see this var str equals hello playground. And here we can begin our discussion about variables. Now, something that is very useful is that if you write 2 forward slashes, it allows you to comment on your code, meaning that the computer doesn't see this. It just treats it as like nothing is there. It doesn't treat it as code because normally if you write something like this is a note, it tries to figure out, okay, what is all this? Is this code? I don't know, this keyword, this is a keyword already, so that's why it's a different color. But if you try to run it, you will see that the computer doesn't know what to do with any of this. So the way that we can write notes inside our code is by using our 2 forward slashes, and the computer registers that as a comment. This is a way for us to write important information on our code about what it does and document what our piece of code actually does. For now, we will use it as a note taker and for a way for me to convey information to you. Now, a variable. This is a term that you may have heard in math in relation to things like x and y, or this may be your first time hearing it all together. Either way, the best way that I like to think of a variable is like a box. Essentially, it has a label on it and it can hold something inside of it. You will find that in your programs you will have many variables, and thus the name that you use for the variable is very important. So let's get started. As you see on this first line already that we have, Swift has already written a line for a variable. So let's go through each piece. The first part is a keyword called var, which lets the computer know, hey, I am creating one of these boxes. I'm creating one of these variables. The following word is the label that we want to use for that variable. We often want descriptive variables, so let's change the name of this to greeting. Do note that the color is a good way to know the difference between something like a label, a name that we're using, or a keyword that's already built in. As you can see, these keywords are pink, and this is just from my color scheme. You may have a different one, but you will see that the color usually all match. So we have import, which is already a keyword inside to say, hey, go get this specific toolbox. And here we have another keyword that lets us say, hey, we're declaring a variable. We created the box, but we also have to put something in the box for the box to exist. And so that's where we go and write the equal sign, and then we write something inside. What we have here is a string, and a string is just a group of characters. You can think of this as just text. Here, the string says, hello, playground. Another good way of knowing what we're dealing with is if you hold Option on your keyboard, you will see that your cursor turns into like this plus. And when you go over a variable, it turns into a question mark. If you click it, it tells you some information about that variable. As you can see here, it tells us that it is a string, as I said before. Now we can go ahead and declare other variables as well. Let's say we want some numbers. Well, we write our new keyword, var. We write some kind of label. So let's say my age. As you see here, I've written my label in something called camel casing. This is because programming languages all deal with labels that have multiple words in different ways. Swift likes camel casing, which is essentially the first word is lowercase, and every word subsequently after that is uppercase. And let's pretend that my age is 11. Now, if we click Option and click on our variable, we see that there's something here called an int that is short for integer. And these are whole numbers that we will be dealing with throughout our programs. So they can be positive, they can be negative, they cannot have decimal points. If we want decimal points, then we have to go and create a double. And we do the exact same thing. So var cake cost equals, and then we put whatever number that we want. So we'll say, I don't know, it's $4.25. Here we have a variable that holds a string, a variable that holds an integer, a variable that holds a double, and to show you that there are other types, let's go and make a Boolean as well. A Boolean is just a binary value that is either true or false. So let's say something like var coding is fun, and we will set that to true. If we go ahead and option click and see what this is, we will see the keyword bool, which is short for Boolean. There we go. We've created 4 different variables of 4 different types. Now you may have noticed that Swift is able to tell what type the variable is according to what value you put in it. This is something called type inference. Essentially, it looks at what the value is and it goes, okay, well, if you've written strings, then this must be a string. However, you can also type annotate specifically what type you want a variable to be. For example, you can write var and then write my integer, type annotated using a colon, write int, and these have to be capitalized. You have to write them exactly how you see them inside when you option click a variable. So you see that this is double with a capital. Same thing here. Int is capitalized, then the equal sign, and then some numbers. Now, for something like an integer, this may seem trivial, but here's an example. You want to use a character rather than a string. Now, a character can only be one character. Strings can be 1 or 0 or more. So if you write var my empty string, for example, you can make an empty string. Check it, and sure enough, it's a string. Check it one more time. There you go. Okay. But let's say we write something like var my initial, and you set it to a. If you check it, you may think, hey, well, it's 1, so it may be a character, but it infers it as a string. And this is not what I want. I want it to be specifically a character, so I can type annotate it and make it a character. It'll become more clear why this is useful as you start to deal with these different types and see what they can do. But for now, just know that it's an ability that you have. Great, so we've declared some variables. But another aspect about variables that is important is that you can reassign them. They are dynamic. They can be one thing at one moment and they can change later on. Code executes from the top to the bottom. So at line 10, anything that was written before it holds true. So let's say on line 11, we want to change what the greeting holds. We don't have to write var again because this would be a read declaration, meaning that you're trying to create it again. It already exists. So what we need to do is reassign. Well, how do we reassign? Well, that's where the name comes into play. Essentially, we write whatever we've declared it. So let's say greeting, and you see that it pops up. Please note that it is case sensitive, and however you've written it before, it needs to be written exactly the same. So let's go with greeting equals, and now you can change it to something else. So let's say I'm gonna change it to 34. And let's just run this. Oh, look at that. It says that I cannot assign value of type int to type string. It is another thing about Swift. It is a typely strong programming language, meaning that you can't just declare that a variable is going to hold strings and then try to put integers inside of them. It will not allow you to do that. So we need to fix this. Now let's put some quotes around it. And now it is the string 34. Again, yet another thing to notice. It is a string. It is not the number 34. You would not do math with this, for example, because it is not the numerical representation of 34. It is merely a textual representation of 34. Something to know. And as we move on to some logic, we will see how that actually influences how you can interact with these things. The way that you would interact with the integer 34 is much different than the way that you would interact with the string 34. This means that from line 4 to 10, greeting holds hello playground. So if we were to call greeting, let's say in line 8, if you run this, you can see here that hello playground comes up in line 8. However, on line 12, when we change it, greeting is now 34, which means, and the string 34, which means that if we were to call it somewhere down here, what do you think would come up? Well, if you guessed 34, you would be correct. Again, it executes line by line, and so you're able to make changes at the time that you want. Now let's imagine that there's something that doesn't need to be ever changed. Something like pi. This is the math pi we're talking about, not the yummy kind. Well, that value is always 3.14 and many other numbers if you know them. But for now, let's say 3.14. Now, this is fine and dandy, but let's say that you want to make sure that at no point pi changes. This is in danger with the way you've written currently because somewhere along your code, if we're working together and I happen to not know that it never needs to change, I could simply write pi and make it equal to some other thing. This would be bad. So is there a way for us to make it so that it won't ever change? Of course. This is something called a constant. It works exactly like other variables, meaning that you can create them and give them a specific name, and you can call them later on. But the one major difference is that you cannot reassign them. Now, if we change this var to the keyword let, we see now that if we try running this, you see that we cannot assign to value pi. It's a let constant. This is a way to prevent those changes to happen. So when we move forward and you're creating your variables, always try to think about whether or not you want them to change later on in your program. Let's go ahead and delete this. And something about constant that you need to keep in mind is that you can use them. So I could call pi later on, for example, in line 17, and it represents 3.14. It just means that because it's a constant, I cannot reassign the value of this variable pi into something else, into another double. Awesome. So now we know how to declare variables and reassign them. We got to see a few different types of variables. We understand now what strongly typed languages mean. And in the next lesson, we will learn how we can interact with these variables to get some results.